Hello, everybody. I think we'll get started here. My name is Aaron Durman. I am an engineer working in the design division for the North Dakota DOT. This session will be discussing the adoption of 3D model-based design, digital delivery, and BMI, or Building Information Modeling. Here to present this topic is Billy Wong, a transportation engineer from Stantec. Billy is a project engineer with 13 years of experience in the fields of transportation and community development. He specializes in urban roadway and transit or rail design with an emphasis on design coordination with other design scopes, integrating civil scopes with facilities and system scopes. In addition to technical design, Billy also focuses on transforming technical design into 2D or 3D visualizations for stakeholder engagement and supporting the development of digital model development on common data platforms. Please welcome Billy Wong.
All right. Thanks, everyone. I guess there's some spots as well if people don't want to stand, but feel free. Good morning, everyone, and thanks for the first session today. So today I'm really thrilled to talk about kind of a revolution that's been reshaping the construction and design industry. So it's really adoption of 3D model-based design, digital delivery, and BIM. So thanks for the introduction, Aaron. Billy Wong, transportation engineer. I'm actually from Edmonton, Alberta, up in Canada, and I'm from Stantec. So my background started in subdivision design, and then into light rail, and now I'm actually in the infrastructure digital practice group at Stantec, and that's where I really get the opportunity to bring these project experiences from my past to assist with workflows and projects from all over kind of United States and Canada. So for me, it's been a real big challenge to kind of go from metric to imperial kind of on a daily basis. Right now, I don't even know like what temperature feels like. I just know it's cold, but I'm used to it. So in this new role, I'm really actively engaged in roadway and bridge design and kind of advancing more so from a workflow support point of view. So in the past and even right now, I can see kind of the industry relying heavily on 2D drawings. But the industry is really quickly embracing the power of 3D, model-based design, and this technology allows us to create, visualize, and manipulate designs in 3 dimensions right at the design stage. It really enhances our understanding of the design, improves our accuracy, and with the goal to facilitate better communication amongst all the stakeholders. But the innovation doesn't really stop there. So with digital delivery, now we're able to share these 3D models across various platforms. We can make collaboration easier and more efficient than ever before. And the intended purpose of digital delivery is really to eliminate barriers, accelerate the design process, and reduce the risk of errors and rework. And then we have BIM. So BIM is not just a 3D model. It's 3D model with intelligence, and it contains detailed information about the building's elements, the systems, and its physical properties to its functional characteristics. And this really wealth of experience and information supports better decision making throughout the design's life cycle, and from design, construction, and also to operations and maintenance. And with the adoption of these technologies, it's not really just a trend, it's a paradigm shift. It's about working smarter, not harder, and it's about harnessing the power of digital technology to drive efficiency, improve quality, and foster innovation. So let's embrace this revolution here. Here's some of the topics I'll be talking about today. First, I really want to establish some of the BIM background. I think a lot of us in this room have heard about it as a concept before, but really get into the weeds of kind of the levels, collaboration side of it. Then I'll move on to MOL, which is an acronym that stands for Model as a Legal Document, because we know kind of the legalities is really important. And so a concept that emphasizes that legal validity of digital documents. in construction industry, and it's really a significant step towards this digital transformation in the industry. Then I'll discuss some of the FHWA and strategic roadmap. The FHWA, Federal Highway Administration, has been very instrumental to kind of promoting and fostering digital technologies in highway construction. And their strategic roadmap outlines the vision for the future and kind of steps that's needed to get there. And then finally, we'll talk about digital delivery. And this is the process of using digital technologies to improve the delivery of projects. It involves the use of digital tools and systems to improve efficiency, effectiveness, and overall quality. Now I'll talk about some of the implementation from kind of my experience, and talking about some of the practical aspects of implementing these on projects include some of the challenges faced, strategies used to overcome them, and the benefits that we've realized. So these aren't just agenda items, but they're kind of the building blocks of our industry's future. Let's go into them, understand them, and see how we can leverage them. So BIM's roots can be traced back to 1970s with the advent of kind of the first computer-aided design CAD systems, and these early systems were primarily used for drafting and didn't yet have the capabilities of 3D modeling or data management yet. So as technology advanced, so did the capabilities of these systems. So in the 1980s to 1990s, so that's kind of when I was still crawling around and learning my ABCs here, we saw the development of 3D CAD systems and the introduction of kind of more parametric modeling. And these advancements allowed for the creation of intelligent 3D models that could be manipulated, analyzed in ways that weren't previously possible. However, it wasn't until the early 2000s that the term kind of building information modeling, BIM, was coined, more so kind of from the vertical architectural structural industry. And this really marked a shift from a focus from kind of the creation of 3D models to the management of information throughout the life cycle of kind of a infrastructure design. So BIM was no longer just about the design, it was about the construction, operation, and even earlier on the demolition of a project. So today BIM is a critical tool in kind of our AEC, architectural engineering and construction industry. It allows for a more efficient design, improved collaboration, and better project outcomes. But perhaps most importantly, it really represents a fundamental change in how we think about infrastructure in our designs. With BIM, and engineering design is no longer just about the physical structure. It's a source of information. It's a resource that we have to manage, and it's a valuable asset in its own right. So to start off, what is BIM? So first, basic, BIM's a noun. Represents a kind of a digital representation and the functional characteristics of infrastructure. It's a shared knowledge resource for information about that design, forming a reliable basis for decisions during its life cycle. But secondly, BIM is also a verb. It's an action, a process, a method of working that involves creating and using these digital models for design, construction, and operation. It's about more than just creating a 3D model. It's about managing information, collaborating, and integrating different aspects within that project. But lastly, and this is something I heard from my colleagues, and I thought it's pretty interesting, BIM is really what you need it to be. It's a flexible tool that can be adapted to serve various needs or different scales of project. Whether you're a designer needing a 3D model, or a contractor needing something like scheduling information, or a manager needing asset management data, BIM can really be tailored to your needs to meet the project. And BIM is not just a technology, it's not just a software or a 3D model. It's a process, it's a methodology, and a tool that kind of redefines how we design, build, and manage our designs. So it's also not a one-size-fits-all. It's a process that can be implemented at various levels, each offering kind of different degrees of complexity, collaboration, and benefits. And I'll talk about kind of the levels. So there's kind of the levels and the dimensions of BIM. So the levels talks about more so it's collaborative efforts. So level 0 BIM, known as pre-BIM, is kind of involves no collaboration. Information is shared through 2D CAD drawings, sometimes even PDFs, and kind of the use of electronic sharing is minimal. And I think we still to this day use all of these different levels. For example, kind of a couple weeks ago, someone just sent me a PDF of a school site in an area, and it's not a CAD file, it's not georeferenced, but kind of need to know where it was, so kind of took that digital information and had to kind of align it within my own CAD file. But moving up, we have level 1 BIM. So at this level, we start to see some collaboration. 3D CAD is now used for concept work, but 2D CAD is still mainly used for those approval documentations and production information. And data is shared electronically, but it's not yet integrated into a single shared model yet. Next is level 2. So maybe this is where a lot of people are kind of more experienced. And this is where we get to see some of the more real power of BIM. Multiple stakeholders now can collaborate on a project using common data environment. And with each party using its own 3D CAD model, these are separate models that are linked into a kind of integrated, federated BIM model. And then finally, we have level 3 BIM, and that's kind of known as open BIM. So at this level, all the parties are collaborating into a single shared model. The model resides in a centralized repository, and changes made by any party are actually kind of visible to everyone. So if the road designer changes the alignment of the road, that immediately, or the stormwater or drainage folks can see that happening. And it allows for real-time collaboration, improved conflict detection, and better project outcomes. And there's no necessarily, I do see in my experience, there is a pro and a con side. With kind of the level 2 where we're kind of maybe sharing things on a weekly basis, you see, okay, now I have an idea of where the design is, but if the drainage person made some changes on Monday, you actually don't see it until Friday or the next Monday that you come in, so that everyone's been kind of diverting paths. But with this level 3 BIM, you see it right away. May not make sense, but you can then start to make some calls and being like, okay, why is this changed here? And then you can see how that kind of improves that collaboration and kind of that risk aversion. And these levels of BIM represent the evolution from that traditional, very siloed working practice to a very fully integrated collaborative process. So besides collaborative aspects, so there's these dimensions. So easier to think of these beyond kind of the 3D as not its physical dimensions, but kind of how we can describe or input information about a design or model. So the first 3 dimension, that's the length, width, height, or X, Y, and Z. Those are the physical dimensions, and they're typically what we think about when we're talking about 3D models. They represent the physical characteristics. However, the 4th dimension, that's time. So when we add time into our BIM models, we can plan and visualize the sequence of construction activities, identify potential scheduling conflicts, and optimize our construction schedules. The 5th dimension is cost. So by associating cost data with our BIM models, we can generate accurate cost estimates, track project costs in real time, and can make more informed financial decisions about the design. 6th dimension, sustainability, involves using BIM to analyze and optimize environmental performance. This can include from things like energy usage or kind of selecting sustainable materials. And the 7th dimension is facility management. It involves adding data to our BIM models that can be used for operation and maintenance of infrastructure. It can include information maybe about a bridge's life cycle, maintenance schedule, and performance. So for example, the Stantec office in Denver was collaborating with the county of Denver, I believe, on a project that placed sensors on a new pedestrian bridge. And those sensors can actually be monitored in real time online. So rather than having to wait for a yearly or monthly scheduled visit from a bridge inspector, relevant and important metrics can actually be viewed and flagged at any time. And then you can see if something does flag, then we can send out that bridge inspector to kind of double check and validate. And these continue onwards, and kind of there's almost an infinite amount of different dimensions. But so for example, rather than maybe, I know from my experience, a curb line is kind of the 3 lines representing kind of the gutter, the face, and the back of curb. kind of in the application of BIM, we would now require that curb object to be defined by that cross-sectional shape. So now we kind of included our first 3 dimensions, but also maybe with information about the construction time per linear meter, maybe about the cost per linear meter, and then that'll get into that 5th dimension, and then even onwards the amount of CO2 potentially to construct and install that per linear meter. So now we can understand the sustainability aspect of that project. So this is just an example. Hopefully you can see, I know it's kind of dark here, but it's a typical, this is one of the projects I've been working on a recent project in Autodesk. So everyone's probably seen this, lots of lines, lots of colors, lots of information. So to a designer like myself who's worked on this project for months, if not years, I can easily interpret what's going on. I see that there's the LRT tracks going on the top. There's kind of a parking lot. There's kind of a shared use path that we're proposing. But to someone who may not have that technical background or maybe much experience with a project, there's a lot of layers of abstraction. You probably have some potential confusion there. So let's take that CAD model and throw into InfraWorks. So again, this is all kind of in the Autodesk space. InfraWorks is a program that I've been using that better takes in kind of 3D information. I can take information from Civil 3D, put in like surface maps from DEMs, aerial imagery, and kind of combine them all in a way I can see it in a more 3D environment without my computer overheating and blowing up. So you can see in that InfraWorks model is now overlaid on top of that CAD line work. It's still a little bit abstract because there's a lot of gray textures and whatnot, but one of the abilities of InfraWorks is that now you can kind of much easily shift that into a perspective where I can see some verticality. I can see kind of the height relationships of different areas. But for those who may not have been on the site, it's really still hard to contextualize. So I'm assuming everyone here hasn't been here, so you don't understand kind of the scale of these elements at all with each other. You don't understand how, if you were standing on the path, how tall things would look like. So this is more so branching off into more the visualization aspects, but I put this into something called another program called Twinmotion, which is really an architectural focused program that runs off Unreal Engine. It's basically like building a video game in real, but using kind of the outputs of InfraWorks, which is really the output of Civil 3D information. And this is the Civil 3D corridor just exported out through that. So if I make iterations on my Civil 3D corridor, I can really easily, through just a couple steps or maybe 10, 15 minutes or so, kind of have an updated design that I can see in this type of visual fidelity. And a few paint bucket tools after, grass was added. I also added some trees in from the software library to match some of those landscape scopes kind of CAD design. And this model also included the lighting. You can see here kind of going from kind of day to night. So we can see the illumination patterns very similar to what was in the kind of street lighting scopes design. However, because a lot of these elements, like the landscape, the lighting, weren't parametric or weren't kind of into their CAD model, it was much harder for me, or it was almost a static branch for me to have to include that in. So as we include more different design scopes within kind of this BIM area, it gets easier to visualize or to get to these points of things where this is much better for stakeholder engagement, because now someone can see, okay, this is how it'll look like, how it'll feel like. I can be, rather than this view I'll never look at from top looking straight down, this is actually the design from my lived perspective. And then I also provided we had some LiDAR information of that building on the side, so having that as the point cloud data makes it a lot easier to give kind of context and location. But next, let's talk about kind of this idea of mold. So when I first started my career about 10 years or so, I remember going down when we got a set of drawings to be kind of authenticated. I remember going down to the print room, had to get the full-size set of drawings, I had to find a big enough table so that the engineer can go and kind of apply their stamp on each page. I had to wait for the stamp to dry and I had to sign it. Then I'll take that set, run it back to the print room so they can scan it, and then reprint multiple copies, bind and staple it, so then we can send it off to the owners, to the contractors, or the people working in the field. So this may still be the reality for many engineers and many firms across North America, but if we kind of speculate and kind of go forward to the realm of digital delivery where we have CAD files, Excel files, different modeling files, how do you stamp a CAD file? How do you stamp a surface land XML file? How do you kind of deal with that? So traditionally, legal documents in construction projects have been 2D drawings and written specifications. And these documents really define those contractual obligations of the parties involved. However, with the advent of BIM, this is changing. So the concept of model as a legal document, is about recognizing that these BIM models are legal documents. It's about acknowledging the accuracy, the reliability, and the richness of that information and to improve the clarity, reduce ambiguity, and minimize disputes with all parties. However, implementing MALD is not without its challenges. It requires changes to traditional contract workflows and mindsets. And it really requires a clear standard for model creation, data management, and quality control. Maybe from the state DOT perspective, or maybe from kind of a consultant perspective as well. It requires a legal framework that recognizes digital models as legal documents. So, because I'm not necessarily from here, so have kind of the North Dakota been using any digital signatures in any way? Is there like a standardized version or way of using that? And have that been applied to using anything other than just kind of like PDFs? No, not yet. So MALD represents really a kind of a step towards digital transformation of construction industry. It's about kind of moving forward, or moving from a document-centric approach to a data-centric approach. It's about leveraging that power of BIM. So kind of from where I am in Alberta or Edmonton, Canada, so a lot of our engineering agency has a standardized digital stamping requirement for kind of all documents. So how we've been trying to adapt with anything that isn't a PDF is we actually kind of throw that, or kind of attach that file in, CAD file, Excel file, within a PDF memo, and then we stamp that digital, or we stamp that PDF. So now that CAD file is contained within a digitally signed version. So you can't make any changes for it, because that is essentially locked by that stamping authority. So that's some of the ways that we've been adapting from our end, with kind of the kind of framework of what we're allowed to do with our digital signature. So switching gears, I kind of want to talk about some of FHWA's initiatives and how those initiatives have been helping kind of the state level DOTs. So this is an initiative that's been really transforming the way we've been approaching highway projects in the United States, kind of called the Everyday Counts, if you haven't heard of it, EDC, and it's spearheaded by the FHWA. FHWA, as I've been learning, is the U.S. Department of Transportation that specializes in highway transportation. Agency's programs are really designed to foster, support, promote safe, effective movement of goods and people on the nation's highways, as well as innovation. And this Everyday Counts is an innovation initiative that aims to identify and rapidly deploy proven yet underutilized innovations that may be born in some states, but kind of have the opportunity to kind of address that through multiple states as well, so it's not really siloed within one state or a couple states. And the goal is to really shorten the project delivery process, enhance roadway safety, reduce traffic congestion, integrate automation. It's about saving time, money, and resources, and can be used for deliver even more projects. So EDC started, I believe, in 2011, and it's based on rounds that are kind of incremented on a 2-year cycle. So currently we're at EDC 7 for this kind of 2023 and 2024 year. And this initiative is not just about implementing new technologies or practices, it's really about creating a culture of innovation where the best ideas are brought to the forefront and implemented quickly and efficiently. The EDC initiative have been really successful in reducing the time it takes to deliver highway projects. And I believe EDC 2 really established an innovation for 3D engineered models for construction. And I think that really laid the foundation for the digital delivery today. And parts of these EDC initiatives from FHWA is leading towards kind of that digital delivery with something known as the Digital As-Built or DABS initiative. And DABS are part of the EDC 6, so the last round, which aims to shift transportation professionals towards a digital data-oriented process for tracking, documenting, and archiving asset information created during project delivery. DABS initiative focuses on enhancing access use and management of highway project data from design to asset management. And DABS have evolved and served as a valuable repository for design and construction information, and it's foundational for a successful lifecycle asset management program. Preserving information in a digital format allows it to be integrated with other discipline data and accessed and analyzed more readily for decision making. And the guidelines set for this level of detail for 3D renderings, because they're intended to exist more as exact records for constructed facility, DABs are required for the highest level of detail, level 400, which ensures consistency and accuracy in the data. And DABs also support effective lifecycle assets and performance management and allows transportation agencies to collect, integrate, and manage information for improved access to asset data, better investment decisions, and streamline project delivery and enhance safety. And this DABS initiative is really a significant step towards digital transformation in the field of highway construction and management. It really not only improves the efficiency and effectiveness of project delivery, but also contributes to that safety and longevity. I believe Iowa, Minnesota, and Utah DOTs are recording as-built information assets during construction. Michigan DOT is developing an as-built or digital as-built approach for utilities during that permitting phase. And several states, including Oregon, Indiana, Montana, and California, are working to incorporate digital data into more effective construction delivery and management workflows. DOTs in New York, Iowa, and Utah are providing contractors with enhanced contract documents using kind of the 3D models as they consider more integrated and streamlined approaches to project delivery. And these EDC programs really grew eventually into the project that produced kind of that FHWA strategic roadmap, and this was originally published in 2021. So the roadmap is part of the Advancing BIM and Infrastructure Initiative, and the initiative is really an open standard-based collaborative work method for structuring, managing, and using data about transportation assets and networks throughout their life cycles. So on the roadmap outlined in this document is intended to help the state DOT level strategically develop a kind of more uniform and nationwide policy framework related to BIM for infrastructure, open data standards and methods for adopting those standards, BIM tools, and a more robust personnel training and upskilling program, effectively creating a framework that can assist in the kind of the independent solution for each agency. And these state-led and FHWA-supported actions can then become the basis of planning, implementing BIM for infrastructure to better deliver projects and transportation services at that state DOT level. And all these programs is an indication that the whole industry is changing. So we talked a lot about BIM. We talked a lot about kind of modeling in 3D. So where does that lead us? So now imagine you're working on a project where you've created your design, whether it be in AutoCAD or Bentley. Now you have a 3D model. You got all your relevant parameters and your BIM information. So what are you going to do with it? So in the pre-digital delivery days, now you would probably make plan sheets. So from those 3D models, maybe in the example of some linear infrastructure, you would probably have like a plan, a profile, some typical sections, and they're all drawn separately. But you already have that 3D model in hand, so why shouldn't that be used as the deliverable instead? And that's the core of what digital delivery is about. What is digital delivery? It's the use of digital technologies to improve the delivery of projects. It involves the use of these digital tools and systems to improve efficiency, effectiveness, and the quality, and leveraging the power of data, automation, and collaboration to drive project success. So with digital delivery status and state DOTs, so across the countries, different DOTs are really embracing it. They've been implementing digital tools and processes to streamline project delivery, enhance collaboration, and improve outcomes. So while the level of adoption varies from state to state, the trend is really clear. Digital delivery is really kind of that future that everyone is inching towards. So what are the benefits? Digital delivery offers, improved communication and collaboration, enhanced decision-making, reduces the risk of errors, and leads to better project outcomes. However, it also presents a lot of challenges. These includes the needs for new skills, new training, changes to our traditional workflows, and the need for a really robust IT infrastructure. Looking ahead, the future of digital delivery is really bright. As technology continues to advance, we can expect to see even greater efficiencies and improvements. We'll see more integration, more automation, and more data-driven decision-making. For example, I know one of the things I've been testing out is this thing called kind of grading optimizer. So you kind of give it some parameters for maybe a site. You can say this needs to be flat, this needs to be sloping down, and then it'll run through hundreds, if not thousands of iterations to kind of get a good earth bounds because you set kind of the outer limit. That's where you have to tie into. So traditionally, someone may have to take that plan. They'll use kind of their know-how to kind of know where you start. You're not going to start crazy high deltas from the existing. But any iterations, you're kind of more one and done. You get your one, cut, fill. You're like, okay, I'm pretty comfortable with that. But now with these more automated process, you give it the process and it runs through those thousands of iterations. So rather than the confidence or the risk of that one and done solution, you have the full gamut of, okay, if this changes, now this is how it will impact the rest of the site. So it gives a lot more opportunity to create a better design. And digital delivery is not a trend, it's a paradigm shift. It's about working smarter, not harder, and harnessing those digital technologies to improve quality and foster innovation. And there's a lot of reasons for implementing digital delivery. So I've listed a lot here. It's very dark in the back. I should have kind of inverted the colors, but a lot of these kind of digital twins, asset management data, constructability, reduce construction costs, improve construction safety, finish on schedule, connected live data. These are all kind of things you've heard about in kind of those benefits of BIM or those literature in the text about the benefits of BIM. So, but I think there's one benefit that really stands out above all the others as the momentum in the industry is kind of going towards that digital delivery. And that's really an overall return on investment because that's dollars and cents. But like all innovation, things take time. And without large data set, it's really hard to understand its true benefits. And there's sometimes too much variation in one project to another. And I know I can't look into a parallel universe where, my counterpart is doing something in traditional delivery and I'm doing something with digital delivery and I can kind of see the exact delta between the construction time and cost. I just can't do that. I hope I could, but can't. But as we understand from past experiences, there's always also kind of skepticism towards innovation. And it's healthy for all innovation to have skeptics, but because it really means that those in the industry who are innovating have to show that these innovations have that net positive effect for the industry. And we're moving more into a decade into the emergence and widespread adoption for model-based design, so I can really be confident, and from even my own experiences, what I'll talk about in a few slides, that there are net economic positives as we head towards digital delivery. So if we've been building roads and bridges all the way in the past, before with our existing methods, why do we need change? Maybe you've also been thinking that since really, maybe you've been thinking that, the difference is only now we have a model instead of plan sheets. But one way to think about the idea is, what is the representation of the design? So in kind of this current plan sheet status quo, the plan sheets are the representation of the design. And the 3D model may have been used to kind of facilitate the creation of those plan sheets, but what the plan sheets don't show, someone doesn't need to model. So the model was kind of useful, but not integral to the process. So now when we think about digital delivery, the model becomes the representation of the design, where it's much harder to not account for the entire, or for the design of something. Even from my own experience, a lot of kind of the tie-in conditions, those are not necessarily things that we may have included in those plan sheets. But now when you have a model, you need to integrate that in a much more significant way. So these models are very integral to the entire process, from the design through to construction, and can even go beyond that. So who's been kind of adopting this, especially in the US? So several state departments in the US have been exploring this, as I've talked about. Pennsylvania DOT, I think they're on the leading edge of this transition. They have a 5-year program called Digital Delivery Directive 2025. I think that's been very impressive. Oklahoma DOT, Oklahoma is implementing kind of that technology advancements with 3D models and digital project delivery. And then I believe a 2023 survey noted there's at least 9 states that have been initiating or completing pilot projects using kind of that model-based approach. So it's clear that many states and agencies across the US are beginning to explore a model-based delivery approach. So I'll show you, these are some of my own experiences. So I'm working on a closeout phase. This is a light rail project I've been working on since 2017. Started off as a preliminary design. The detailed design started in 2020, where we kind of started just fresh. Didn't carry over any of the files from previous towards kind of that new detailed design. This project was the extension of an existing light rail transit line for about a mile, and there's 2 new stations within this extension. It's in my home city, Edmonton, Alberta, and this extension was in the middle of an old downtown airport. You can kind of see maybe remnants of runways in the background there. So I did have the luxury of construction without being kind of on the front door of residents and businesses. So that was good on our project side. But some history about Edmonton's LRT extensions, that they have been plagued with constant delays. So the previous line that this is extending beyond, that one was delayed by a year. And then there's another line that goes kind of towards the southeast of Edmonton, and that was also opened in the year that this project completed, but it was actually delayed by 3 years. So lots of cost overruns, lots of delays. So when we started on detailed design here on this project, there was a big push from the project management side to be collaborative. I don't have the cross-section here. You can kind of see it, but our cross-section included 4 rows of trees, 2 sidewalks. You can kind of see the one sidewalk on the very left there. Cycle track, that's kind of the darker gray that's surrounded by the 2 kind of topsoil areas. And the LRT, all within about 55 feet of right-of-way space. 30 feet of that was actually the tracks, which is on the right here, where you couldn't put any utilities underneath because they didn't want to break up the track in case you have to maintain the utility. So in 25 feet, we had to fit 1 stormwater main, 2 water mains, 3 LRT-based duct banks, communications, right-of-way, traction power, and the electrical. And because of all the snow and the freeze-thaw cycles in Edmonton, the client actually wanted all those duct banks to be gravity drained as well. So within that 25 feet, we actually had 4 gravity drain systems. It's a lot of coordination, and any misses that we had in design could amount to a lot of construction overhead and delay. So the design team really challenged ourselves with really mostly working in 3D, and there's actually few scopes that haven't worked on kind of the pipe networks before too, so they've really adopted and understood the benefits of that to create surfaces, pipe networks, and to reference everyone else's designs in a live working file. So we're talking kind of that BIM level 3, all within a common data environment. And our deliverables to the contractors, so we still weren't in digital delivery yet because we still kind of created the traditional plan sheets as our legal documents, but we also did send the contractors our models, surface models, pipe models, more as a reference than as legal documents. So it's, like I said before, it's really hard to say what would happen if we didn't utilize a model-based approach, but the construction of this extension was recently completed in mid-December 2023, and it was on budget, and actually it was completed more than a year ahead of schedule. So I think that was a really big testament for being involved in a very model-based design right off the get-go and kind of reaping the rewards of it. I'm also currently working on a project in Calgary, Alberta for a series of highways or freeways and interchange improvements. And there's probably over, I believe, I was checking today, over 100 different designers and engineers from different offices, different scopes, different consulting firms as well, that's working on this simultaneously through and through. So on this project, everyone is working on a common data environment. So this is the Autodesk Construction Cloud. So my role on this project has been to really utilize the tools that's built into this CDE environment to help the team coordinate. So what I'm showing on screen now is kind of a web viewer from the Construction Cloud, where all of the pipe networks and kind of the surface are visualized together. And the team has been really harnessing tools like the automatic clash detection and issues tracking as almost a secondary check. So how I've been telling all the design scopes is like, you need to be sure of your own design and you need to do your own checks, but we also have this tool which can really help benefit as a second check, because I know if you're working on something with this type of complexity, it's really hard to show every single thing in your own working file. So there's sometimes some of the things that could be missed, but because everyone has their own model files, we can put all of these together and can take a look at all of them in kind of one model environment. You can pan through them and it'll actually flag for pipes that are actually hitting each other. So note, this still has a traditional plan sheet deliverable. However, I think Stantec has been really developing our own workflows and kind of increasing training within our kind of staff and designers for this model-based design and kind of that digital delivery future. So I do know it's almost lunchtime, so this is kind of the team that I've been working with. So within our infrastructure digital practice group, and we're really constantly striving for innovation. So our group is led by John Barone, and Brad has been really on the forefront of assisting DOTs. Right now we're working with Pennsylvania on kind of their Autodesk adoption. I think Brad is also working with Texas as well for kind of their digital delivery workflow. So feel free to contact any one of us if you have any questions or would like to talk more. So with that, thank you very much for everyone's time and have a great day and a great conference.